we're not going to go any deeper than 20,000 feet because
20,000 feet of drilling sounds a long way to me. Is this something that you're comfortable with? It stands?
Absolutely.
Really?
See, that's what's exciting.
Is there a growing sense in the oil and gas industry that, oh, gee, we have all these talents?
People are curious and they're wanting to get, basically on the clean side. So yeah, a lot of people, I'm reaching out to them and a lot of people are reaching out to me as well. We actually have a term sheet with Meta to do 150 megawatts of geothermal power. So we're very excited about that. And if you think about with the AI boom and the growth of electricity demand is just very powerful.
Hello, I'm Bryony Worthington, and this is Cleaning Up, brought to you this week from New York Climate Week. My guest this week is Cindy Taff, CEO of Sage Geosystems. Cindy spent 35 years working for Shell in the oil and gas sector. She built up a team of 350 people and managed a budget of over $1 billion. But she recently left all of that to start working on a geothermal startup. Please join me in welcoming Cindy Taff to Cleaning Up. Cindy, thank you so much for joining me here in New York. I'm really looking forward to this conversation. And I wanted to kick us off with just the first question, which is always, could you introduce yourself in your own words, please?
Oh, absolutely. And thank you for having me. And I'm so excited to be in New York here during Climate Week. So spent the day yesterday at Geothermal House. Anyway, but yeah, my name is Cindy Taff. I'm the CEO of Sage Geosystems. So my background is oil and gas. I was with Shell for 35 years. My last few roles at Shell, I was vice president. And my last role, I was vice president running their global unconventional wells organization, meaning that we had well drilling, well completion operations around the world.
Amazing. And so firstly, Geothermal House. Now, so that's quite a thing because obviously Climate Week is a huge circus of events every year. And so all the geothermal events have been brought into one venue. Is that what's happening?
There's an organization called Project Innerspace that is run by a very enthusiastic geothermal influencer, Jamie Beard. And so she decided to bring Project Innerspace to New York Climate Week. And so yesterday was a day dedicated to geothermal. There was a location where all the new startups, probably 15 of us were located. And so people got to walk around and meet us and talk about our technologies. And then upstairs was panels and speakers. And so it was a full day dedicated to geothermal.
And I want to take a step back. And so you're in the oil and gas sector. What degree did you do? You came through an engineering background. And so tell us a bit about what it was like in the oil and gas sector as a female leader.
Absolutely. So mechanical engineer by training. But, when I went to work for Shell, I was doing petroleum engineering. My dad worked in the oil and gas industry. He was a geophysicist. I didn't want to study rocks like he did. I liked the mechanical side. And so, the oil and gas industry was fun. I would say as a female, I was one of very few females. And sometimes that was an advantage and sometimes that was a disadvantage, right? So I've had people throughout my career, men, take me under their wing like a daughter, which I really appreciated because it can be intimidating, right? Mm-hmm. But then I've had people that, didn't think females should be in engineers, much less in the oil and gas industry, and you just have to work through those challenges. So, but I would say on balance, it's been a plus and a minus, and I've thoroughly enjoyed working there, but I'm very much enjoying having pivoted now to geothermal and being able to use those skills that I learned from the oil and gas industry, in particular the knowledge of the subsurface, which we learned very well in the oil and gas industry to do now energy storage and geothermal, right?
That's amazing. And so I'm really interested in, did climate change play a role in this pivot? Could you remember kind of hearing about climate change from within the sector?
I did late in my career. In fact, my team at Shell was responsible for doing cost estimates for geothermal wells. And so they would come to our group as coded projects. Sometimes I would know the details, and sometimes I wouldn't even know the details because they were coded projects, kind of secret projects. Then my team would do a cost estimate. I knew about them. And what I couldn't understand is we never pulled the trigger and drilled these wells. And I'm thinking, okay, Shell, you're an oil and gas company. One of your key, people in oil and gas, some of their key skills are understanding the subsurface, so geologists, geophysicists, drilling wells, and building facilities, right? And if you look at, those are technical skill sets. If you look at leadership skill sets, I would say, project management, driving down cost,
contract negotiation, procurement, all of that.
Exactly. Yeah. The oil and gas industry has all those. So when Shell would then not do geothermal, but they would do wind and solar, I just never really understood it because I felt like we were leaving a lot on the table, not pursuing geothermal in the energy transition. So when Ben Van Beurden became the CEO, I was really proud because he put a very definitive energy transition plan in place, but none of it included geothermal.
Yeah. And was that purely cost, do you think? Or because it's a tension, right? If your whole core business is oil and gas, and you see that having a future, maybe you're going to invest in the things that are, adjacent to your core business in order for it not to threaten your core business. Like, I guess certain renewables work well with gas, for example, and so variable renewables plus gas equals an oil-friendly transition, whereas geothermal kind of replaces the need for the gas, right? It's a sort of surround solution. It does 24/7 provision. Was there any element of that, or was it something more practical, like these projects just didn't make as much return?
I think it was the latter. I think the projects just didn't make as much return, so they couldn't wrap their head around, going and doing them. And maybe they were relying now on, companies that were already out trying to figure out how to drive the cost down and improve the efficiencies of these systems. So I think it was more around return than anything else.
And now, pivot forward to today. Why is geothermal having this resurgence? Like, why is there suddenly so much interest in it? And are any of the oil and gas companies interested, or is it still an emergent new sector?
Yeah, one thing to mention is the current production of geothermal around the world is about 17 gigawatts, but it all comes from these huge pools of hot water just below the surface. So if you think about, Iceland or the geysers in California, the challenge is that only represents about 2% of the geothermal resources around the world, and it's a very unicorn geology. So now what we're going after, and next generation geothermal is going after, is rock that is deeper, it's hot, but it doesn't have those huge volumes of water to bring it to the surface. The advantage of that geothermal is that it represents like 50% of the geothermal resources around the world, meaning that
obviously much wider playing field to go at.
Exactly.
Right?
You can put it closer to grids as well. So now you have the oil and gas industry pivoting into it because they know how to drill deep, and you'll need multiple wells because you get 3 to 6 megawatt net output for a 2-well pair. So you're going to have to drill a lot of wells. And so now you have the oil and gas industry pivoting in order to drive costs down. And so going back to your question, I think there's a renewed interest by the oil and gas industry. And I think there's just a renewed interest on how to unlock that hot, dry rock geothermal, which we can then put just about anywhere in the world. I mean, you still have to have the heat at a certain depth. So, but I think that's why there's so much interest.
And we'll come on to the specific technologies that Sage are developing. But I'm so interested. So when did you then make the leap from oil and gas sector, which is very safe, nice pension, I'm sure, to, I'm going to start a startup technology company? What was that journey?
Well, my co-founders, so Levering and Lance Cook, which these guys have a history of developing some very complex technologies for the oil and gas industry. They were influenced by Jamie Beard. She kept, I'll just say bugging them. It was so sweet. Like, she would send them pictures of kitchen utensils, like an egg beater, and say, why can't we think about how to harvest the heat with, kind of a downward, circulation of water. And so, at first they were like, oh, can you just go away, right? And then finally they were like, and Jamie's so smart, she's an attorney by training. So after a while they said, hey, actually Jamie's got a good point. And so they started modeling what we could do with geothermal, and I was still at Shell, and then they called me and they said, you need to just come. And I'm like, I'm on my way. So
really?
Yeah.
And so, but why was it such an inviting proposition? You must have had some sort of, was it the excitement of the new company, or was it the climate aspects, or a combination?
It was the excitement of working with two guys that I knew could crack the nut on geothermal. It was the ability to use my skill set to affect the energy transition. I mean, if I did solar or wind, I could affect it because of my, leadership. But not my technical skills. So it was the ability to work with these guys that I know have, created technology, developed technologies before. It was the ability to go in the energy transition, and then also to use my skills in that energy transition.
Fantastic. So Sage Geosystems is the company based out of Texas.
Houston,
right in the heart of the beast. And you've got two technologies that you under your company kind of auspices, and they're based on the same principle, aren't they? That you're drilling into the ground, creating a closed system into rock that's dry to use the heat, or to use the pressure that you can store things under in the ground. So tell me a little bit about the two technologies, and then we'll I'm sure there'll be more questions that come from that.
Well, you just did a great job explaining them, but let me go into a little bit more detail. So yes, so energy storage, we drill a well, and we're looking for a low permeability formation. So really the opposite type of rock that the oil and gas industry needs, and actually not the same rock characteristics that actually other geothermal technologies need either. We put a fracture in that rock, and then we operate that rock like a balloon. When the rock is not 150 degrees C or greater, so it's cooler than that, then we use that for energy storage. So to your point, we when energy demand is low, we use the electricity, which is now excess, to power an electric pump water into the fracture, and then balloon it open like a set of lungs. Mm-hmm. And then we can wait until that demand peaks, and then we can open a valve, and that fracture is wanting to naturally close. And when it does, it pushes the water under a lot of force back to the surface. We put it through a Pelton turbine, which is like a kid's pinwheel. It spins the Pelton turbine and generates electricity. So energy storage is intended to be paired with wind and solar. Mm-hmm. And wind and solar's done such a great job of greening the grid. We now need to help wind and solar move the energy to a time of day when it's needed, and not just when the sun's up and the wind's blowing, right?
Yeah. And it's particularly necessary if you're in a grid that doesn't have too many interconnections. Perhaps it doesn't have, natural hydropower to back it up. And that kind of describes Texas, right? Texas, for whatever reason, has remained quite islanded, has now a lot of wind and solar. So is that why Texas is such an exciting place for this?
Well, Texas is an exciting place, and we're not just working in Texas. I want to be clear on that. Yeah. But Texas is an exciting place for us because we can get permits very quickly. So we're a startup company. We're trying to take care of our investors' money very, particularly. Mm-hmm. And so we don't want to be sitting around waiting a year and a half for a permit. So California and Texas are kind of neck and neck on which one has the most solar and which one has the most wind. So two great places to be. We just actually announced a MOU with California Resources Corp yesterday. So we'll be, partnering with them to develop storage and geothermal. But Texas, again, we can get a drilling permit in a matter of weeks. So we can move quickly for our, first of a kind and our first commercial facilities.
Right. So but also the grid needs you, right?
Yes.
Presumably, right? Because it's quite islanded and it has all this variable, right? Yeah. And that's so interesting about the permitting. So, because, one of the things that's going to be potentially challenging is you use the fracking word, the F word. And, that's now gone through so many kind of obstacles, and especially in Europe where, many of our listeners will be, fracking is a kind of almost a dead end. So talk to me about how that's affecting your plans and your business.
No, and yes, it's really a good question. So yes, we do use fracking. I will say that we have talked to two of what I would consider the toughest regulators. So the regulators in Germany and the regulators in California. We explained what we're doing. We're very transparent. We are creating a crack in the earth, but we're using a very heavy fluid, a non-toxic heavy fluid, meaning that the fluid does the majority of the work. So we don't have to bring in a huge amount of trucks, and you don't have a frack fleet driving down the road, damaging the road.
What's a frack fleet? I can picture it.
Yeah, a frack fleet is about, depending on, it's about like 40 trucks. You've got a blender that, mixes the fluid with the proppant. And by the way, we're not using proppant. And then, you've got pump trucks, which have these high pressure pumps, but you need many, many of them if you're going to be doing a high pressure frack. Because we are allowing the weight of the fluid to do the fracking, we can just frack with the pump that's on the rig.
So what is you use the word proppant that I'm not familiar with. So tell me the difference between what's a traditional frack and what you're doing.
Absolutely. So let me get back to the regulators, though.
Oh, yeah.
When we were talking to the regulators, again, they said, what you guys are doing is really what we call stimulation versus fracturing, because I think they relate fracturing to what the oil and gas industry does. So, to your question, what the oil and gas industry does is they use water, they pump at very high rates and high pressures, and they use proppant or sand. Once they create the fracture, it keeps that fracture open. So we're not, we're not using high pressure or high rates, so we don't need all the trucks. And so they call what we're doing stimulation versus fracturing. And again, we're just trying to be transparent on what we're doing in the subsurface. So we're fine. I mean, it's great news for us that they don't consider what we're doing fracturing. But to your question, we do take it serious. We know that we're going to want to do a lot of community outreach so they understand what we're doing.
Because there's a few risks all bundled up here. Like people perhaps don't like the idea of 40 trucks trundling down, and also the substances that are being used, and the worry about the toxicity and potentially contaminating water, etc. But they also worry about seismicity or earthquake, right? So talk to me about what the risks of earthquakes are.
Yes, and that's a great segue. So the way our technology works, I talked about the lungs. So we create a fracture onto one well, and we open it up like a lung. And then, for geothermal, you time 2 wells every 12 hours, kind of like a 2-cylinder engine. And that's how you create the 24/7 baseload.
And is that so that you can allow it to heat back up, or how does it? Why do you need the two? Because,
you're moving water. At some point, our lung will deplete. And so we're moving water until this lung depletes, and then we'll move it back.
Because it's literally like pouring storage from one to another. Right, I got you.
But, induced seismicity, we do take it very serious, but because we're not drilling 2 wells, fracking between them, and then moving water between them, we have a lower risk of induced seismicity because we have, you called ours kind of closed loop. I mean, it's a self-contained fracture. We know where the water is. If the way induced seismicity happens is if you are either producing fluids or pumping fluids past a naturally occurring fault. If our lung contacts a fault, we're going to lose water and the efficiency of our system is going to go down. So we already think the risk of induced seismicity or earthquakes and tremors, just to be clear, is very low. However, we do take it very serious. We look at the geology. We actually put monitoring stations. We hire a third party so that it's arm's length. In fact, we're working with the University of Texas. They will publish all of the data online, And so people can see that. And so, so we do think the risk is very low, but we understand people's concerns and we want to address them and be very transparent about what we're doing.
But as you say, certain regulatory regimes are tight enough that if you can get it past there, it should be a sign that there's, like Texas doesn't have the most kind of high reputation for regulatory safety, but California does. So I guess that's part of the plan, is to get it through one of those harder, or Germany would be, if you got it through Germany, then
exactly
you've really nailed it.
Yeah, I mean, like I said, we've had conversations. We have not applied yet for permits in either of those locations, but they gave us the confidence that they did not worry about what we were doing and didn't think it would, induce earthquakes. And so I think we're looking forward to, we can. The other thought is we can do the technology, maybe where it is faster and easier to get the permits, and we can then prove that, look, we're not going to induce earthquakes. And so maybe the other places that it takes a little bit longer, there's more scrutiny, that they'll be fast followers, right? So I think we'll be fine.
Well, and also, I'm always very interested in narratives and words matter. And I'm wondering if actually you need to coin a new phrase, which is ditch the fracking language, because the use of fracking for oil and gas is doing a completely different job in different rocks for different purposes. And maybe you need to call it stim geothermal or something. You need to coin a new word that everyone can associate with your new way of working, because it is very different, right? It's not extracting a fossil fuel out using all these techniques. It's
a very good point. And you're not the first one that has suggested it. We just, I guess we like to be very transparent with what we're doing, and we're not. Yeah. It's a good point. It's a really good point. So
So let's go then think about energy then. So we talked a little bit about storage, and that sounds very useful in grids that have got high variable renewables. I can see that being, I did an episode on hot rocks in a box with Anand Gopal from Energy Innovation, and we talked about how thermal electric storage is going to emerge as a class of technology. So I'm excited about that. And actually, before we move on, you have a specific project that you've announced in Texas that's collaborating with a coal-fired power station. Do you want to tell us quickly about that?
Oh, absolutely. I wish I could show pictures, because we're actually
we can.
building it.
We can put, put some audience, there's some pictures now on YouTube.
So yes, we have actually broken ground for our first commercial energy storage facility. It'll be a 3 megawatt. We're targeting 6 to 10 hour duration, 70 to 75% round trip efficiency, which is very competitive with other long duration energy storage. But to your point, we are building it on land that we've leased from a lignite coal plant. So San Miguel Electric Co-op, lignite coal plant. The coal plant just got a USDA grant to build 400 megawatts of solar. So the reason that they wanted to lease us land is it gives them a front row seat to our storage, and they can consider that to pair with their solar in 2026 when they build it. So very exciting.
And is this the first of a kind demo for you, or is this how many have you done?
We did a demo last year, but this is our first commercial facility. So we are actually going to be hooking up to the ERCOT grid. The interconnection study we're in progress, so we're hoping to get interconnected. We'll actually be commissioning this facility by December, so 3 months from now, which is pretty quick. And then so as soon as we can connect to the grid, then we'll be buying and selling electricity just to power the facility, because the lignite coal plant won't be, putting their solar in until 2026. So that would be a future potential application.
Yeah. And talk to me a little bit about the financing of that then. Have you got IRA credits? Is there something in Texas that gives you like a balancing payment, or how does the finance work?
Yeah, so we raised we just closed our Series A, $30 million. So part of the Series A is paying for this facility. Inflation Reduction Act tax credits are wonderful. We are going to be applying for those tax credits. We think we may qualify for 30 or 40%. We're working with a consultant to determine that. There's tax abatements in Texas that we'll apply for, so property tax abatements, but no other incentives from Texas as of now.
Right, and no kind of balancing market payments that you can access. It's just pure buy and sell arbitrage on the price.
It is now, yes, for now. Texas doesn't have capacity payments, but there is a bill that was passed last year that in, I think, 2026 or 2027, they won't initiate capacity payments, but if you don't have capacity, you'll get penalized. So we think that that's going to help in Texas influence, wind and solar producers to use storage. And we think our storage is the perfect storage. So for example, we did some studies for the Middle East, and they gave us a price point for solar of 2 cents a kilowatt hour. And they said, okay, what would be the blended LCOE for the 24/7 production with your storage? 5 cents a kilowatt hour, which is pretty cheap. I mean, it's cost competitive in Texas, and so it's a pretty cheap form of energy, 24/7 energy.
And increasingly, countries are looking to add. Obviously, they're adding more solar and wind, but they are asking that there's the corresponding investment in the storage in order to make the grid management easier, right? Because, Europe's had the advantage of a very interconnected grid, hydro power that helps back it off. So trying to replicate what Europe's done elsewhere isn't quite as straightforward as it might have first appear, right? So all these novel forms of storage, again, I hope, emerge as we move out into different locations with much weaker grids and much less agile demand, I suspect.
Absolutely. It's funny you mentioned hydropower. We've actually had 2 companies just recently reach out because they want to do storage combined with their hydropower because the dispatchable energy is just such a resource that they're needing in these areas that they're working on. So it's just been... I'm excited about our energy storage because I think it's going to really revolutionize the way storage is done and stabilize the grid, to your point.
We'll be back with more from Cindy Taff after this short break.
Cleaning Up is brought to you by the members of our new leadership circle. So that is Actis, Ecopragma Capital, Euroelectric, Gilardini Foundation, KKR, National Grid, Octopus Energy, Quadrature Climate Foundation, and Wärtsilä. For more information on the Leadership Circle and to find out how to become a member, please visit cleaningup.live. That's cleaningup.live. If you're enjoying Cleaning Up, please make sure that you subscribe on YouTube or your favorite podcast platform. And leave us a review. That really helps other people to find us. Please recommend Cleaning Up to your friends and colleagues and sign up for our free newsletter at cleaninguppod.substack.com. That's cleaninguppod.substack.com.
So then moving on then to the other technology, which is now more about harnessing the heat to displace fossil fuel energy. Is it what temperatures are we talking about? What depths? So what can you replace easily in the fossil stack? What's the best application?
Well, it's what you're talking about is geothermal, baseload power. So, we can replace coal, we can replace natural gas. I would say our energy storage can replace natural gas peaker plants, right? So that's another application. But so for geothermal, we are doing the same thing as you mentioned that we're doing in energy storage. So we're using the downward fracking with the heavy fluid. We're operating the fracture like a lung. But now we've drilled the well deeper. So we need to be in rock that is at least 150 degrees C. The depth is going to depend on where you are. If you're in California, it could be as shallow as 5,000 feet. If you're in, Texas, it can be as deep as 18,000 feet. I will say we're not going to go any deeper than 20,000 feet because...
20,000 feet of drilling sounds a long way to me. Is this something that you're comfortable with? It's standard?
Absolutely.
Really?
See, that's what's exciting is we know the subsurface. We actually have a test well in Starr County, Texas, again. And this well was drilled in 2008 by Shell, by my team, to a depth of 19,000 feet, a temperature of 235 degrees C. So it's what the oil and gas industry knows how to do. So drilling these wells, the only thing about going deeper than 20,000 feet, then you have to get into specialty rigs, and there's not many rigs, and then your costs go up. And so that's why we limit it to 20,000 feet. But, it could be as shallow, like I said, 5,000 feet in California, or as deep as 18 or 19 in Texas. But that heat now allows us to not only harvest the pressure energy like we do with storage, but the heat now gives you the generation. And so when you bring it to the surface, you can convert the heat and the pressure energy or mechanical energy into electricity. And then you have baseload power.
So just thinking then about thermal efficiency, like some people would say, look, this is just too inefficient. There's not enough heat exchange surface area. This is never going to work. Thermodynamics doesn't support this. How have you approached this?
I love that you asked about surface area. So let's go back to the F word, the frack word. The reason why fracking is so attractive in the geothermal industry is exactly what you're saying. You need huge surface contact area to have that heat exchange in the earth. And so what fracturing actually allows you to do is create that huge surface area in less than a day. I mean, I would say in a matter of hours, versus if you try to lay pipe into the hot rock, you're going to have to lay thousands and thousands of feet of pipe to get the same surface area. If you think about cutting that pipe down the middle and kind of opening it up, that surface area has to be equivalent to what you're creating with the fracture. So, but to your point, you're spot on. The heat transfer from the earth is a challenge, and that's what we're focused on. We're not focused on. We know once we start drilling wells at scale, we're going to be able to drive the cost down. The oil and gas industry's done it for years. My team at Shell took out 50% of the cost in less than 5 years, and the wells got longer, and they put in, we were putting in more frac. So we know we can drive down the well cost. We have to figure out what I would say the geomechanics and the thermodynamics of the system, which is getting the heat out of the rock efficiently, getting it to surface, and then efficiently converting it to electricity. And so we are actually focused on both of those things. But to your point, that is what the industry is working on, and that is what needs to be overcome. So that's why we're using the fracturing system, creates a big surface area. That's why we're using the lung approach, because basically we're letting Mother Nature pump the water back to the surface, meaning that you have less parasitic load, meaning your net output's going to be higher. And then one other thing that we're working on is we've built a supercritical CO2 turbine, which actually will more efficiently convert the heat to electricity because it uses a hybrid Brayton cycle versus an organic Rankine cycle. So your efficiency should be 15 to 20% versus the turbines used today. It's about 8 to 12%.
Yeah,
so more electricity.
Right, because I was going to come to that. So we've got the question about the heat exchange, and then the net, how much energy in to get how much energy out. And then you've got the conversion from this relatively low temperature steam into power. And so your first prototypes are using what to do that? You said the open cycle.
We're going to be using, for the first project, we will be using off-the-shelf organic Rankine cycle, because we don't want to introduce too many new technologies. So we'll use off-the-shelf ORC.
Which is not very efficient, right? That's the 8 to 10%.
You know what? I will say that over the last 40 years, there's companies out there that have been building them. They've done a great job getting the highest efficiencies out of these systems. So it's just they're limited by, the cycle, right? So for the first one, we'll use the off-the-shelf just so that we don't have that technology risk. But for future ones, that's when our CO2 turbine is going to come in. And because CO2 has a higher density, the equipment's actually smaller, meaning that you can build it cheaper. But we also use this hybrid Brayton cycle, which means you're getting more electricity per unit heat that you're putting into it.
But that is a novel turbine that you're building, so you have a third product that you're working on, or is that something that's coming from another third party?
No, it's our. So we're working with Southwest Research Institute, which is a not-for-profit research institute. Same research institute that's actually working with the DOE on other CO2 technologies. So it's our IP. I would still say, though, our two main business lines are storage and geothermal, because we want this as a tool to improve the efficiency and drive down the cost. So our background in oil and gas is, we've been trained to drive down the cost. So looking at the cost per kilowatt hour is our main focus. And when you do that, you look at it in an integrated system approach where we're looking at the well cost, but we have to look at the power plant cost, and you have to do it in parallel, because sometimes you'll make a change in the well that'll negatively affect the power plant or vice versa. So we're doing it in parallel, but it still underpins geothermal.
Yeah. And talk to me a bit about then degradation or essentially, heat does dissipate. It runs out and cools down. And so how long can you keep running, or what do you do to sort of combat that kind of entropy that's kind of inherent in the problem, right?
And that's a great question. So with geothermal, you have to take thermal degradation into account. So thermal degradation, we've modeled and estimated it to be about 10% over 5 years to a distance of about 200 feet. So you take that into account in the well design, but you also have to take that into account in the OpEx. So after 5 years, then what we're going to be doing is move that fracture to basically rock that has virgin temperatures, and then we'll cycle the fracture there while the original fracture or the first fracture is reheating. And so, yes, you do have to take thermal degradation into account in geothermal. The other thing that you have to take into account that a lot of people don't think of, and I didn't know when I was in oil and gas, is that your net output is also dependent on your ambient temperature. So the cooler it is, the less that you're having to spend to cool the fluid, meaning that your net output's going to be higher. So your net output actually changes seasonally, and the same power plant that you'll build in, say, Texas is not going to have the same power output as one you would build in Canada.
Interesting. Yeah. And the Canadian one will be better. Right, interesting. I've heard that before, actually. I met a very interesting gentleman who talked to me about the tar sands, the work they've done on geothermal up there. And because they have this big temperature switch between summer and winter, the ground acts as a store, right? You can dump if you want cooling in the summer, you dump it in, and then by the time the winter rolls around, you've got this heat store. And so through the year, it's kind of acting as it makes it more efficient, basically. So the countries with the highest variance in temperatures are actually going to be quite good for geothermal in its broadest sense.
It's funny you mentioned that. We learn a lot from people ahead of us, whether it's the DOE dating back to the 1970s. There was a project in Hanover, Germany, called the Genesis Project, and they weren't generating for electricity, but they did storage. They would store on the weekends for district heating. And then they would produce it into the buildings during the week when people were working. So we've studied that project and, like I said, other projects. And so we're learning from people, some great minds before us on how to move ahead. And I think without that knowledge, we will have had to spend much more money to be where we are today.
Yeah. And it might well be, I mean, as all startups do, you might pivot and find, opportunities where you weren't expecting it, because I'm wondering that if you're not converting into power and losing whatever it'll be, 70% in that process, direct heating, district heating might be another. Right? I'm sure it is an application you're looking at.
Absolutely. In fact, we just signed an MOU about a month ago with Elsin in Romania. So they use some very old Russian technology dating back to the 60s for their district heating, and they want to move to clean energy. So we can do, a pretty shallow well, because you don't have to go very deep to get the amount of heat that they're looking for district heating. And so to your point, yeah, and we're actually talking to entities in Lithuania as well for district heating. And, as you said, you're not converting that heat to electricity, so the efficiencies are huge. They're very high.
So geothermal then, it's having a moment. You're here in New York. As a sector, have you got so Project Inner Space is very interesting, right? Because the oil and gas sector probably knows the most about the underground of any sector. Are you having to redo all of that knowledge? Is that knowledge public? Where do you go to for your map of, I want to know where the hottest parts are with the right rock? Is there a public source of that, or is it all held in, the oil and gas sector? Or how do you target the right places?
No, it's definitely public, and I would say it's definitely getting better. So there was, and there still are, maps from Southern Methodist University, SMU, that have been out since 2010. So it's kind of the go-to. Stanford just released maps, I think about a month ago. And then Project Inner Space, this, Jamie's organization, they have something called GeoMap, which not only has the heat maps, but it has grid. You can see where the grid is. You can see where faults are. You can see, they have these layers that are just amazing.
Have they done everywhere? Because they started in Africa.
They started in Africa,
Yeah.
but I'd be lying if I told you everywhere they have it, but they have released, I think, in the U.S. because we're looking at it as well. We're using it as a tool. Yeah. And so not only are the tools getting better, because the GeoMap is just amazing with all these different layers, but I would say that, like when Stanford released what they released, the heat map is getting different, which you have to think that people are, scientists are going in, they're analyzing the data. I think a lot of the temperature data was probably from drilling oil and gas wells. And if you think about it, oil and gas people, they kind of wanted to know what the temperature was, but not to the exact degree that geothermal wants to know. So they may have just, pumped a, cold drilling fluid in the hole, and then they took a temperature, and then it kind of, makes the temperature not be as accurate as it could. So I think the temperature maps are getting better, and yes, they're definitely out there, and they're in the public space. And nobody's hiding them or trying to sell.
That's moving us ahead. And then I have one question, which you might tell me is complete nonsense, but I remember speaking to somebody about the thermal qualities of coal seams. So, because when you're thinking about transition from a political perspective, the really big challenge is like the kind of loss of social kind of the economic value and the social value of the fossil fuel industry today, right? It's fairly concentrated, but where it is concentrated, there's a lot of capital, social and real capital invested. And so countries which are very coal dominated, it's the mining as much as it is the power stations that causes the friction around the transition. And this was suggested that coal seams actually act as an insulating layer. So you get higher temperatures beneath them. I don't know if this is true, but I'm kind of hoping it's true, because if you could find a technology that could help coal mines transition, as well as the coal stations and the downstream power infrastructure, then I think politically things get a lot easier. Is that completely kooky?
That's a great question. I have not heard that theory. I think it would, coal typically is not real deep. And so when I think about the heat that we need for geothermal, it's going to be pretty deep. I'm not a geologist, so it's a wonderful question, but I'm not really sure what the answer is.
Continue my research into this. But it seems like, as you say, a shallow, you're going to be using that for heat, right? For manufacturing, not for power. It's not going to get you to those temperatures. Anyway, Interesting. So,
but to your point, for district heating, it might be perfect.
Yeah, or for heat for manufacturing, a lot of our fossil demand is converted into low grade heat for manufacturing, and the food system relies on it. There's so much heat that's needed.
So our energy storage, I know I kept talking about the mechanical or pressure energy of the water. To your point, we actually have a waste, which is a heat, which can be used for district heating, can be used for food processing, some, plastics or, So to your point, that low grade heat, there's a lot of use for it. What we think about, though, is we really need to be co-located to those processes because it's hard to transport heat. But yeah, for what you're talking about, I think coal seams might be interesting. I'll be asking our geologist Mike Eros when I get back.
Let me know what he says.
Okay.
We can put the notes in the show notes. And so you're here in New York. You're going to go back to Texas, and I'm really interested in how do your former colleagues now. Do you meet up? Do you talk about this? And is there a growing sense in the oil and gas industry that, oh, gee, we have all these talents. Why is it that Cindy's doing it over here with a startup? How are you still in touch? How?
Oh, absolutely.
Yeah.
Absolutely.
How's it going? What are those conversations like?
People are very curious. In fact, we just hired somebody that worked for me at Shell. We hired him a couple of months ago, and he's loving everything that he's doing. He's actually in New York this week too. But yeah, people understand that the energy transition is full on, and they have skills. And again, it's not just the drilling or completion or whatever. It's the project management. It's the ability to drive down costs. So they know they have the skills that can really make an impact. And people are curious, and they're wanting to get basically on the clean side. So yeah, a lot of people, I'm reaching out to them, and a lot of people are reaching out to me as well.
Well, I'm going to end with the question that we always end with, which is there anything that you are currently occupied by or you want to share with our listeners that we haven't covered so far?
Yeah, maybe I should mention that we had a press release a few weeks ago. We actually have a term sheet with Meta to do 150 megawatts of geothermal power. So we're very excited about that. And if you think about the power needs of data centers, it's just, amazing where we're going with, I don't know about you, but, you hardly Google anything anymore. We used to think Google was fantastic. Now you search with Chat GPT, right? But with the AI boom and the growth of electricity demand is just very powerful. So having Meta, as one of our partners, building geothermal to power their data centers. And we've got our own vision to build gigawatt scale power with either energy storage paired with solar or with geothermal. So that's going to be on the horizon.
That's exciting stuff. But data centers always as well need cooling, right? So and I imagine there must be some sort of ground source cooling solution that they could also be, it seems that we've forgotten that we've got this great resource under our feet, which can, keep us cool in the summer and keep us warm in the winter. And I'm hoping that these data centers, because they tend to go where the demand is,
yes,
which can be very hot places, and the cooling requirements must be enormous.
Yeah, the cooling requirements, like you said, for the data centers are huge. We are looking at using part of the heat to do cooling through, I think it's called adiabatic cooling. We're still in the early stages of studying it, but we think that could be a great synergy with data centers. Not only giving them electricity to power the data center, but as you said, their cooling needs are huge. So being able to satisfy their cooling needs with some of the waste heat from the system.
That's amazing. Thank you. I think my final question possibly is, so we've got narrative questions around fracking and people's reactions to that, which it sounds as if there's a way through, but there must be other kind of regulatory enablers that might be needed to kind of get this industry like turbocharged. Have you got like a wish list for policymakers or politicians for how this can be helped?
Yeah, I would say the wish list is grid interconnection timelines are just very, very long. Whether policy can change that or not, I can't see where it can hurt. So I think that's one of the challenges. In some areas, permits, I'm thinking about the U.S. at least, it takes 5 years to get a permit on federal land. And I know they're working on it, but 5 years is a long time, right? So if you really want to encourage, clean energy through geothermal, you've got to shorten these permitting times. So I think those are really mainly what, If you look around the world, I guess grid congestion also is a challenge. So it's grid interconnection, grid congestion is fixing the grid, or, we are looking at doing, off of the grid or behind the meter power, which I think is going to be very effective in protecting the electricity for residents, right? You don't want to impact just regular consumers with data centers and the power needs of industry. So behind the meter is also a nice solution. But
yeah, and I'm guessing that with those grid congestions, it's a function of how we treat our grid capacity. Like, if it's congested at only certain periods, that for you, that's fine, right? Because you want to come into a grid that's got variable congestion. So it's having a smart approach to the grid connections, isn't it, that we probably need?
Yeah, and then just grid interconnection timelines. Again, in Texas, they're supposed to be really good, and they're still a year and a half, right? And then you get into other places, and we're hearing 3-4 years, and some don't even give estimates anymore because they don't know how long it's going to take. So I think the grid interconnection is just something that we need to solve together, because everybody wants clean energy, everybody wants more energy, and we need to be able to figure out how to get that to everybody.
Yeah. And is that why partnering with an asset owner like the coal-fired power station in Texas is good, because they have the pre-existing grid connection, right?
Absolutely. Yeah, I would say it's a couple of things, but yeah, coal plant existing assets are very good to repurpose. So you think about, like you said, the switch station. I just learned a couple of weeks ago that you can actually repurpose the generator to do synchronous, which you need once you get a lot of solar on the grid.
The synchronous condensers that basically hold the frequency.
Correct.
Yeah.
You said you didn't have an engineering degree. That's amazing.
You hang out with all these engineers, you fix things up.
Water, of course,
abstraction licenses and all the permitting that you get from an existing site, right?
Yeah. And just excitement, to be honest with you, to help a coal plant move away from coal.
Well, Cindy, thank you so much for joining me today. I hope you have a great rest of the New York Climate Week. Maybe I'll be able to come and visit you in Texas. I would love that. As someone who grew up watching Dallas as a child. I'm wishing you all the best with your projects.
We would love to have you in Texas, but you'll have to wear steel-toe boots and a coveralls.
And a Stetson. Can I wear a Stetson?
Yeah, you can wear a Stetson, yeah.
Excellent.
But it won't be Dallas style.
Okay.
Thank you so much.
Thank you. So that was Cindy Taff, CEO of Sage Geosystems. As usual, we'll put links in the show notes to the things we referenced in our conversation. And my thanks go to Eleanor Kagan and Oscar Boyd, our producers, to Jeannie Harrison, our researcher, and to the growing team of people who help make the podcast happen. Join us next week for another episode of Cleaning Up.
Cleaning Up is brought to you by the members of our new leadership circle. So that is Actis, Ecopragma Capital, Euroelectric, Gilardini Foundation, KKR, National Grid, Octopus Energy, Quadrature Climate Foundation, and Wärtsilä. For more information on the Leadership Circle and to find out how to become a member, please visit cleaningup.live. That's cleaningup.live. If you're enjoying Cleaning Up, please make sure that you subscribe on YouTube or your favorite podcast platform and leave us a review. That really helps other people to find us. Please recommend Cleaning Up to your friends and colleagues and sign up for our free newsletter at cleaninguppod.substack.com. That's cleaninguppod.substack.com.